Hello everyone, hope you're doing well. Welcome back to my channel. Today we're at day 8 of the January daily LeetCode challenge. And as you might be knowing, we are getting questions on the topic of strings. And to be more precise, they're also trying to get you to, they're trying to get you going around the topic of tries. Okay, what are tries? We'll get to know this. So in this particular question, we will be seeing some of the, brute force solutions. After that, we will also see the try solution. Though I feel this is not the right problem to begin with a try solution, but still, there is a solution available for try. So I will show you the way that I have done it. So I will show you both Java and as well as Python versions of the same, and we'll also see try solution at last. But again, I will say, I will show you the time, that is the comparison of the you know time taken, that is in milliseconds, how much it is taking. You'll get to know that the try solution is not the right solution for this kind of questions, but still, because maybe they are preparing you for a hard question on tries, for that reason they are expecting you to know the basics of try. That's why they are giving this kind of easy questions. Maybe that is the reason. So I am also following the same, and I'm also going to teach you the basics of try in this question. But again, this is not the right question to solve using a try data structure. Okay, so this is a disclaimer before I start the video. So now coming to today's question, it is 3042, count prefix and suffix pairs, and this is the part one of that question. Okay, so what all we are given, just see here. So you are given, okay, let's see the input first. As you can see, we are just given an array of strings. Okay, as simple as that. So what you have to do, you are given a zero indexed string array called words. Let's define a boolean function called is prefix and suffix that takes two strings. Okay, string 1 and 2. Is prefix and suffix string 1 and string 2 returns true if string 1 is both prefix and suffix of string 2, or false otherwise. Okay, so it's very clear. See here, the order is also important. String 1 is the first parameter, string 2 is the second parameter. Okay, so it returns true if the first parameter is both the prefix and suffix of the second parameter. Okay, for this function, for example, is prefix and suffix of this is the first parameter and this is the second parameter. Okay, so is true. Why? So let us see the this string. If you see, the second string is beginning with the same string. Okay, this and this are same, right? Similarly, if you see the second string, it is ending with this, and the string is so the idea here is string 1, that is the parameter 1, is both the prefix and the suffix for the second parameter. That's why, as you can see, they are returning true for this. Okay, they're returning true for this, right? And yep, you can go through that again. And yeah, in this second example, or that telling you, it is a prefix but it is not a suffix. Okay, for that reason it is false. So always remember, it has to be both prefix and suffix, only then this function will return true. Okay, fine. Now return an integer denoting the number of index pairs I and j such that I is less than j, and is prefix and suffix of word of I comma word of j is true. Okay, so see, this part is very very clear to remember one thing. I has to be less than j, point number one. Second point is that we'll have to pass them in this particular order. Okay, so always the word belong to the smaller index will be here, and the word belong to the larger index will be here, and then we have to see, see whether this particular function is returning true or not, and the other is it. Then you have to count those pairs. Okay, number of pairs which are satisfying this particular property. So I hope you are getting. Let us see the example one first. So see here, what we have to do, always take a smaller index, and then among all the indexes that appear to the right of it, just see whether this particular string or word is a prefix and suffix for the word towards is right. Okay, for example, I am taking this as my base now. Okay, so I will check first this, whether the index number one, okay, index zero word, okay, which is a prefix and suffix here. Okay, so obviously a is a prefix and suffix here, so we are adding one to our answer. Similarly, a is a prefix and suffix here, so we are adding another one to our answer. Answer is 2 now. Okay, similarly here a is a prefix and suffix here, so our answer is now 3 as of now. Okay, next, now we'll come to this particular word. Okay, now this will be our as you can see here, the word I, or you can say this is the parameter one. Okay, str1. So str2 will be all the words which are toward the right of it. Okay, so now we have to test whether aba is a prefix and suffix for the words which are towards its right. Okay, so let us see now one by one. So this particular string, okay, aba is a prefix as well as a suffix for this, so our answer is 4 now, because we are adding plus 1 to it. So 3 plus 1, it is 4 now. Okay, in this case, no, aba is not a prefix and a suffix here, because aba, the length itself is much greater than the length in this. Okay, fine. Now the last word here, for this we'll have to see whether for the words towards the right, whether this particular string is a prefix and suffix or not. Okay, so the only word towards the right is this. Obviously the length is much smaller than this, so it cannot be a prefix and suffix to the word towards the right. Answer is 4 now. Okay, so they have given you the detailed explanation, you can go through it. Only thing that you will have to remember here is this particular part is very very crucial. Okay, remember this part. I has to be less than j. You should not be comparing in any order that you want. Okay, I has to be less than j. So idea is very simple. Take any one particular word, then try to see whether this word is going to be prefix and suffix for all other words towards its right. Okay, that is how you have to do it. That is what they are trying to tell you through this. I hope you are getting this point. Okay, and you can go through the other examples. They have given three examples in total. You can go through them. If you see the constraints, since it is easy question, so the constraints are very minimal. You can obviously solve it using the brute force approach, and I will show you one of the Java solutions using brute force where it is beating 100% of the test cases. Okay? One important point here is all the letters are going to be smaller case English letters. So when I'm showing you the the try solution, this point will be a good point to consider, and this point will be very important while evaluating the space and time complexity in the try solution. Okay, so this point will be useful during the try solution implementation. Okay, for now we will see the brute force approach. See here, this is the Python brute force approach. I'm doing exactly the way they are expecting. Okay, so I've defined this particular function here which they were talking about on. This is prefix and suffix, the same function I've defined here as well. Let me zoom in and let us go through it. Then I will show you the Java equivalent of the same. Okay, see here what I'm doing first. I'm declaring the answer. Okay, it will store the pairs. Okay, that's what is the question, right? We are being asked to count the index pairs ing. Okay, which are satisfying these properties. So this is going to be answer. It is initialized with 0. Okay, I'm capturing the length of the words and then I'm defining a function. Okay, in Python you can define a function inside another function. That is what we are doing. Okay, this is one function. We are defining the second function inside it. Okay, what this function will do? It will take two words. Okay, the way that I am going to give the input, we'll see that now, is that this word is going to have an index which is smaller than this particular word. Okay, this thing we'll have to ensure, because remember that is what is the condition given. Okay, that is what is the condition, right? So what we are doing, see here, if the length of word 1 is greater than length of word 2, that is the case that we saw it. See, word 1 is supposed to be a prefix and suffix, then we have to return true. But since the length itself is going to be much greater than the length of w2, remember it's greater than, it's not equal to, it's greater, strictly greater. Okay, for that reason we'll have to return false. So what is the first condition? It is going to check that whether the string which was supposed to be the prefix, the length of that is greater than or is much greater than the, that is strictly greater than the length of the original word or not. Okay, so if that is not the case, we have written false. Okay, as simple as that. That is, this string cannot be a prefix suffix because the length itself is so greater compared to the original string. Okay, fine. Now comes the base condition. So I'm going to use a simple Python function. The same I will show you in Java also. These are inbuilt functions for this. Okay, I'm just checking whether this, for the second word, it is starting with double one or not. Okay, that is whether double one is a prefix for W2 or not. This is the first condition. Similarly, I'm checking whether the first word, that is double one, is going to be a suffix for the W2 or not. Okay, for that, how I'm going to check? I'm going to use the ends with function. Okay, W2 dot ends with W1. That is, I'm going to check whether W2 is ending with W1 or not. Similarly, whether W2 is starting with W1 or not. Okay, so this particular thing is going to check whether W1 is a prefix or W2 or not, and this is going to check whether W1 is a suffix or W2 or not. Okay, if both these conditions are true, remember both conditions has to be true, then we will return true. In all other cases, we will return false. Okay, as simple as that. So what I'm going to do now, see here, I'm going to start the first for loop. Remember, now function is over. So this is the function, it is over now, right? Now I'm going to start the for loop using from 0 to n minus 2. Why n minus 2? I will tell you. See here, the way these things are defined. See, I has to be less than j. Okay, just a second. I has to be less than j. So the idea here is this particular word which has to be paired with this word only. This is the only way for that. Okay, so for that reason, what I'm trying to do is the first word is going to be between 0 to n minus 2 index. Similarly, the second word is going to be I plus 1 to last index. Okay, that is n minus 1. Okay, remember I plus 1 is very important here, because in order to ensure that this condition is true, you will have to take it in this way. Okay, I is going from, that is, I is going to the first word, that is the word which we are trying to make it as a prefix and suffix. This is going to the first word denoted by index I. Okay, the second word is going to be denoted by index j. It has to start from I plus 1 till n minus 1. Okay, but I value from 0 to n minus 2, right? We are just checking whether is prefix and suffix of words of I comma words of j, that is words of I is going to be the first word for which, that is, this particular word is supposed to be the prefix and suffix for this particular word. Okay, if this condition is being, see, this is the function call, right? If this function call returns 2, we are adding 1 to the answer. Okay, this is the function call. If it returns 2, we are going to add 1 to the answer. Otherwise, we will not add anything. And finally, we return the answer. Okay, let me quickly run this and show it to you, because it's a simple, I'm not wasting much time here because this is a very simple one. I'm sure that even if I give it to you in the comment section, you can go through it and understand by yourself. Okay, so yeah, as you can see, this is clearing all the test cases. So yep, now coming to the Java solution for the same. Yeah, this is the Java solution for the same. In Python, sorry, in Java, the only thing here is you cannot have a function inside another function. Okay, for that reason, I am creating this function separately. I am creating it as a private Boolean function. Okay, private in the sense that it will only be called from function which are again inside the class. Okay, this particular function will be called from functions which are already inside the class. Okay, for that reason I'm keeping it as a private. Okay, as simple as that. Fine. It's exactly same way that of the Java. Remember that. Sorry, the Python solution. See here, we're declaring two words here. Okay. I'm first of all, I'm just checking whether w1 dot length is greater than w2 dot length, strictly greater than w2 dot length. If that is the case, return false. Okay. If otherwise, if the w1 is a prefix of w2, that is w2 dot starts with w1 is 2. At the same time, w2 dot ends with w1 is 2. That is w1 is a suffix also for w2. Then we have to return true. Okay. In every other case, return false. Now I'm just capturing the n, that is the length of the words. I'm initializing the answer. Then I'm same thing, going from 0 to n minus 1, sorry, 0 to n minus 2, and j is going from I plus 1 to n minus 1. Okay, as simple as that. Remember, since it is I plus 1, always this condition will be true. Okay, always. Okay, just a second. Yeah, always this condition will be true, right? Then I'm calling this function for these two words of I comma words of j. And if this particular function returns 2, okay, if this function returns 2 here, then we are going to increment the answer by 1, and we are returning the answer at last. Okay, after the for loop is over, we are returning the answer at last. So let me quickly run this also and show it to you. As you can see, this is clearing all the test cases. And if I can show you my submissions, as you can see, Java submission. Okay, let me open it and show it to you. It is beating 100% of the test cases. Okay, so the Java submission is better than every other case. Though we did in brute force, still it is beating everything. Okay, now coming to the most important part, the try approach. Okay, so what is the try? See, this again the not the right problem. See, the idea here is, if I after explaining the try solution, you will be saying that why the hell are we using try here even? Okay, so yep, that is the case. I am not sure why the lead code is playing such a trick to you, but try is not the right thing to do here. Okay, I am saying this very, very frankly. You can even go to the comments and check it out. I've even commented in the solution below that try is not the right thing to use here. Okay, as simple as that. Again, only if they want prefix, then okay, try is the best solution. But they want both prefix and suffix, then try is not the right thing to use. Okay, as simple as that. But still, just because they are trying to teach you this, because this question has a tag of the try data type, I am showing you how it works. Okay, so what I'm going to do first, see, before you have to learn try, what is try? See, try is basically a tree. Okay, it's just a tree. Only thing here is all the nodes are going to represent a particular character. Okay, as simple as that. So only thing that I can say to you is, I have in the day 9 video. Okay, this is the day 8 video. In the day 9 video, I have already uploaded a very detailed explanation of what is try. I have taken multiple samples and pictures there, and I've explained to you from scratch. Okay, day 9 problem is the very much g- you know uh, you know I can say like the perfect application of try data structure. Please go to and see the day 9 video of the January daily code challenge. This is the date video. In date video, this is not the right actually application for try, but still we are doing it just in order to know the data structure. Okay, as simple as that. So try is basically just a tree. Okay, so first of all, I'm declaring the node. Okay, each node basically will have the characters. Okay, key value pairs. Here there are going to be 26 key value pairs. Why? As I mentioned, see here, all the letters are going to be lowercase. For that reason, at most every character is going to have 26 characters. Okay, key value pairs. So every pair, for example, let us say A. Okay, A means the next character is A. So I will be having this will be storing the key will be A, and the value will be a pointer to the node which is representing A. Okay, simple as that. So this is what a node is. Then this is the try class. Okay, so this is the try class. In the try class, what we are doing, see here in the constructor, what we are doing. First of all, we are declaring a root. Okay, root is going to be a node. Okay, as simple as that. And similarly, since I am in the construct itself, I'm passing a word. This particular word will now be inserted. Okay, I'm calling this function. What is this function? This function is this one. Okay, as simple as that. So you don't have to call this separately. So what I'm doing is, in the constructor itself, I'm passing this function where the word will be passed here. Okay, as simple as that. So what will happen? See here, basically I'm going to insert every character in this particular word to my try. But how the solution works, I will show you to you. Like till now, you have not seen how the solution works. But just try to think of it in this way, that yeah, see here, what we'll do is, for example, let us say I am here. Okay, I am at this particular string. So I will construct a try here, and I will insert only a single word. Remember, in this solution, only a single word is being inserted into the try, which is a very, very bad thing. But again, they want you to learn in this way. Okay, you have to insert only a single word in the try. Again, remember, in the real life application, this is not at all the right way to do it. But in this solution, we're doing it. Only single word will insert in the try. What we'll do, all the words towards the left of it. Okay, for example, these two words. Now, for each of them, we will check whether this is going to be prefix of this word or not. Similarly, whether this is going to be prefix of this word or not. So this is how it will be. Okay, that is one particular word we will insert in our try, and then all the words towards the left. That's all these three words we will test whether they are possible prefix for this or not. Remember, only prefix. For suffix, we are going to use a different strategy here, which I will come later. But just understand in this way, try will work only for prefix. Okay, as simple as that. So for suffix, what we have to do, we have to reverse the string and we have to use it. Okay, as simple as that. So for now, I'm just showing you this part. What we are doing here. See here, very simple. I'm taking the node, which is the root now. For each character in the word to be inserted, okay, each character in the word to be inserted, I'm just checking whether I is in the next character or not. Okay, if it is not in the next character, create a node for it. Okay, if it is there, okay, simply move to the next node. Okay, as simple as that. If it is not there, create a new node for it and then move. If it is there, no need to create a new node, simply move to the next node, as simple as that. Okay, now this particular string will be called when we're trying to see if a particular prefix exists or not. Okay, so we are doing the exactly same thing what we are doing here, but in this case we'll have to return false if the character is not existing. Okay, see here, I'm just taking the root for each character in the prefix that I'm trying to see whether it's a prefix or not. I'm checking that if I is not in the next character, that is in this particular mapping, if the character is not present, that means we will have to return false. This could be there in any stage. Okay, remember that. If it is present, what you have to do, we have to simply go to the the value pointed by this C. We are checking I, right? I is a character. The value pointed by this will be a node. So I'm just going to the next node of it, as simple as that. Okay, so this will keep continuing till all the characters are seen. If let us say this whole for loop exists without returning false, then we will return true. Okay, this is how it will work. Since only a single word will be inserted into the try, so it is more like a linked list. Okay, I'm telling this thing very frankly. Remember that my intention is only to give you the right idea here. Okay, remember, this is not a good solution. I again tell you, this is not a good solution, but yeah, it can be used to learn try, as simple as that, right? Yeah, so see here what is being done now. Okay, yeah, I'm declaring answer, I'm capturing the length, and then I'm going through each of the words. Okay, starting from 1 till n minus 1. Okay, now I'm creating the try. Okay, I'm passing words of I in my try. Okay, to check the prefix, and similarly I'm reversing the current word. Okay, I'm reversing the current word and I'm inserting another try. Okay, this is the second try, so I'm calling it the reverse try. Okay, this will be used to check the suffix. Okay, as simple as that. Now what I'm doing, now I will go through every word which is towards its left. Okay, please understand this point. This point is very crucial. You will not get it easily. Suppose this is my I. Okay, so this will be inserted first of all in a, okay, as it is to my try, and then I will reverse it and insert it in my reverse try. Okay, now I will be checking whether this is a prefix or suffix of this or not. Okay, that is all the indexes which are less than the current index. Okay, that's what we are saying for j in range I, that is all the indexes which are less than I will be checked now. Okay, as simple as that. So what we are doing here, see here, if try dot check if prefix exists for words of j. Similarly, if reverse try dot check if prefix exists dot words of j in reverse. Okay, as simple as that. We are just reversing words of j. Okay, if both is condition true, they see this what we are checking. This will tell me that whether words of j is a prefix of the current word or not. Similarly, this will tell me whether words of j is a suffix for the current word or not. If both is considered true, we have to add one to the answer and then we return the answer. Okay, as simple as that. Again, this is a very bad approach according to me. Okay, because we are storing the data. See what we are doing for every word. If you see here, no, for every word we are creating two tries. And again, this is a very unnecessary thing, because try is something where you are supposed to multiple words, but here we are only going to show one word. Okay, so that, for that reason I am criticizing the solution. This is not the right way to do it, but don't know why LeetCode has tagged this question with a try data structure, and they expect you to learn this. Okay, so yep, yeah, I have shown you the structure. You can, okay, let me run this and show you to you. Again, this is clearing all the test cases, but okay, let me show you the submission time. Okay, so as you can see, the, yeah, this is the latest one, that is the fourth one. As you can see, this is the try one. As you can see, the runtime is 28 milliseconds. Although the Python solution using brute force had 10 milliseconds, the Java solution has 2 milliseconds, but the try solution is going to take 28 milliseconds. Okay, and as expected, Java solution is always going to have a very huge memory consumption. Okay, so as you can see, the brute force solution is going to very huge memory. Even Python is taking less memory than that, but yeah, Java is very faster. Python is not that fast, but it is taking less memory compared to Java. Okay, so yep, you can know these things. But as you can see, the try solution, which is option number 4, is going to take 28 milliseconds, which I can say is around, okay, 14 times higher than what we can get using brute force in Java. Okay, as simple as that. Or maybe if you only want to compare Python with Python, so the Python brute force is 10 milliseconds and Python try solution is going to 28 milliseconds, which you can say around 3 times more. Okay, something like that. So yeah, friend, that was all for this video. I just wanted to teach you how try works. I don't want to simply teach you brute force selection, because brute force I think anyone can do. My aim was to create the try video and show it to you. That's why I did. But I will again say my humble request to you: go and see day 9 January delete code challenge video. In that I have explained in detail of how try works. Okay, so yep, friend, that was all for today. If you like my efforts, please do subscribe to the channel. This really gives us a lot of motivation to continue further. See you tomorrow. Thanks a lot.